Assalamu alaikum, my dear fellows and students. Once again, most welcome. I hope you will be fit, fat, safe, and sound. Today we shall discuss about the Banach Contraction Principle, which play a keystone role in a fixed point theory. Before going to discuss the Banach Contraction Principle, let's the definition first. It is the definition of a metric space along with the three properties. The first one is the property of a non-negativity. The distance should be positive. The second one is the property of a symmetricity, and the third one is the property of a triangular inequality. All these properties will have to use in the proof of the given theorem. The second one is definition of a contraction mapping. Here distance function of tx dy is less than equal to c times distance function of xy, where c belongs to the open interval of 0 and 1 is a constant number. If c is equal to 1, then the t will be considered a non-expansive mapping. Let's see the given statement from the screen. Here we shall discuss 5 step in the proof of the given statement theorem. The first one is the Picard iteration of a sequence we have described in an easy manner, easy mechanism. x1 is equal to t of x0, x2 is equal to t of x1, and up to so on. xn plus 1 is equal to t of xn. This is called Picard description iteration sequence. The second one is step 2. Use the contraction mapping, whether the Banach contraction principle, whether it is a Cannon type contraction principle, or whether it is the Chatterjee type contraction principle, or your own made contraction. First of all, we take its two element consecutively, x1 and x2, and write it in a operator form t of x0 and t of x1 like this, and apply the contraction c time distance function of x and y. That is, x0 is like a x and x1 is like a y. We get the following step. Next, apply distance function of x2 and x3. Write it first in operator form like this, t of x1 and t of x2. We get c times distance function of, that is like x, that is like y, then distance function of x and y. In the same manner we get for it for the n times, but before going to see this, put the previous value distance function of x1 and x2, which is the like term like to this, and its value is this one. Substitute these values for further process, and we get series to power 2 times distance function of x0 and x1 up to so on for n element of the described sequence. Distance function of xn plus 1 is equal to distance function of t of xn minus 1 and t of xn, that is t of x, that is t of y. Same way use the operator values, Banach contraction, c times distance function of that is x, that is y, and we get this menu, and make in the same way for the next steps. Distance function of xn minus 2, decrease it for the x0 and x1, same mechanism with the same way for nth terms and nth times we get the nth. Same like this, distance function of xn plus 1, xn plus 2, like this we get series to power n plus 1 distance function of x0 and x1, and for n and much more. The third step is to make the iteration sequence to be a Cauchy sequence. For Cauchiness, for any positive integer m's greater than n, we described it, and here we have to use the triangular inequality in between xn and xm. First of all, xn plus 1 we take a triangular inequality, and secondly we take xn plus 2 between the xn and xm. We substitute the two triangular inequality, and we take it for n times in triangular inequality, and we write all the elements in a horizontal addition form, and we substitute the following properties at the place of distant function xn plus 1. For any positive integer, the third one step to make the iterated sequence to be a Cauchy sequence. For any positive integer m greater than n, we have to accumulate all the elements between xn and xm of the described sequence. The distance between the xn and xm, first of all we have to use the triangular inequality of the third property of a metric space, which we have made between xn and xm for first time. And secondly, in the second step, we made for xn plus 2 and xn plus 2 between the element of xn and the element of xm. And in third step, we made for m times less than greater than n times the triangular inequalities with the same mechanism with the property of a third property of a metric space, and put all these values which we have described above. Series to power n times distant function of x0 and x1, and distance like this we have mentioned above, series to power n plus 1 distant function of x0 and x1, and up to so on. We take the distant function of x0 and x1 common from all these summation of the terms of the sequence in horizontal form here, like this you can see from the screen. And secondly, series to power n as a common from all these constant values multiply to the times distant function of x0 and x1. We get it is an geometric infinite series like this, like this here. S of infinity is equal to a1 divided by 1 minus r. Infinite geometric sequence, we take the common ratio between the consecutive terms of a sequence, like this you can see from the screen. When anything not equal to 0 raised to power infinity, we get the element of a 0, so its distances between the element of sequence in a space shrinks to a fixed point. So xn is a Cauchy sequence in a complete metric space x. Now we proceed to the fourth step, which is a fixed point, like this. T of x is equal to x. Here we put we take it like this in the distant form, distant function of x and tx less than equal to distant function of x and xn plus 1. Here we again put the third property of a metric space, triangular inequality xn plus 1 and xn plus 1. The first one step will remain same, and the second one term will be we have to write it in a operator form. T of xn xn plus 1 is equal to t of xn, and apply the contraction c times distant function of t of x and t of y, that is xn and x. When n approaches to infinity, it also will leads to the 0. So t of x is equal to x. T of x make as a fixed point, you can see from the screen. And the fourth one, if possible, let we take y not equal to x be another fixed point in a space, then t of y is equal to y, and if we take z, then t of z is equal to z. Let's see from the screen, distant function of xy is equal to distant function of x. When x is equal to t of x, then y will be equal to t of y. So will be equal to c times distant function of x and y, which is a contradiction. After cancellation of distant function of xy and xy from left and right, because c will lies in 0 and 1 open interval, as we have discussed above in the Banach contraction. So there will be the only fixed point x. So there is not a possibility of another fixed point in a space. So x is equal to y. So comment positively and like for the more videos. Thank you.